What's up, YouTubers? So, a lot of you commented and got excited during the previous video where I tested preheating plates and how much of an effect it would have. And a couple people had mentioned something to the effect of, well, what about 140 amp MIG welder on 120? And I'll be honest, I wasn't really going to test that simply because I know that the results will probably be far more of a difference, because in the previous test it was only about a 6% strength increase by preheating the plates, which was less than I would have thought. But I had said in that video that the preheat would probably matter a ton more when you don't have enough power to weld something. And like I said, I wasn't going to test this, but I thought, well, you know what? I kind of want to know with absolute proof as to what the difference is, so that's the point of this video. I am going to weld this with settings that I verified on my welder are about 145 amps of output. And we're going to see if we can weld 3/8 plate and what the strength difference is with preheat. So let's get into it. So what I'm going to do is I'm going to weld both of them on preheated plates, and I'm going to bend and break one towards the face and test away from the face. And this is like worst case scenario. So undersized welder by far, like you should have no business welding 3/8 plate with short arc MIG with a 140 amp welder. But we're gonna find out if the 400 degree plus preheat makes a difference with a 140 amp MIG welder. I think, my opinion, both of these are gonna fail miserably, but hey, that's the point of testing. We might be surprised. Think to yourself, make an opinion right now, and let's see if you're right or wrong with the results. Let's get rolling. All right, so I kind of lied to you guys, but in a good way. Okay, calm down. I ended up doing an extra 2 sets of plates because I thought, well, I've never actually done a brake test on 120 volt values, so really low values, so 140 amp output. So we don't have a baseline. I wasn't thinking. So what I did is these two are unheated, these two are heated plates. We're going to bend one of each towards the face and one each away from the face, so that way we have consistency. These are all the same size plates and everything. Someone had asked in the previous video. But let's just do a quick look at these while these are cooling. All right, so these were the unheated plates, and we can see some pretty clear cut. Let me get my hand out of the way. You see how roped up this is and how cold this toe is? This one I must have slowed down a little bit, so that start really cold. Well, then once I got going, it kind of got a little bit better, and I likely just took longer. These, just by looking at it, are they terrible? No, but they aren't any good. So what does that leave us? Well, let me move these out of the way. Let's look at these that were done on preheated plates. And my God, there is a staggering difference between these on the preheated and without. I mean, not only does the weld look better, it's wider, it's flatter, the toes don't look that cold. This is kind of okay. This one is looking way better. And of course, this one, I ended up, as I'm welding, the wire kind of got ahead of the plate and then missed it, shorted out. I would have liked to have filled that in a little bit better. That's my bad. I just wasn't paying attention to where I was at. Now, the preheated plates have more spatter on them. Like, you look at the amount of spatter here compared to, like, there's no question there's more spatter, I would say, on the preheated plates. But you look at the difference, like, holy shit, that's quite a difference there. Like, this is nice and smooth. So this will be a far better test to see whether or not preheat actually makes a difference, because in this case, I bet it's going to be a lot more than 5% that we saw in the 6% in the previous video. So I'm going to let this cool off a little bit because it's still smoking hot. Yeah, it's melting the tip of my pencil off. And we'll brake test them and see what we got. All right, let's brake this sucker, and we will start on the cold plate. So this was done no preheat. Let's brake it. 69.3, it already reset itself. That is an abysmally low number. Just to put it in perspective, normal MIG is high 80s to 100, so we saw a pretty significant loss of strength there. Now let's do the preheated plate. $68. It's the same. Wow, that's shocking. I couldn't have predicted that. All right, let's bend test them the other way. The previous test didn't really show much of a difference, shockingly, so we'll see what happens here. I'll do the colder one first, which is this guy. To be honest with you guys, you can place your bets now. I don't think either one of these is going to pass the brake test away from the face. And the reason is, well, for one, the welds are pretty small. And two, I just don't know how well that's even bit in. And at some point, it's going to have to cause an issue. So let's get the brake in them. Wow, that's a shock. It held. I'll put a little bit more pressure on that just for old time's sake. Right, trying to flatten it out, but this is a pass. Yeah, that's probably enough. Wow. All right, well, if the cold plate passed, I think we know the answer as to what's going to happen with this guy, but might as well break it too. Huh, we might have a failure. Yep, we have a failure. Very interesting. Huh. Well, let's go back to the work table and look at it. So, I know you can't see that well, but interesting results. We had a pass on the cold plate run at 140 amp MIG weld settings, and we had a failure on the preheated plate. So that's pretty interesting. What I'm going to do, I'm going to actually break these all the way down, and we're going to look at it and see if we can't see some clues as to why this happened. All right, so here is the preheated plate on the right, cold plate on the left. There's no question that the preheated plate has slightly more penetration on the end. I mean, you can see original plate edge, no plate edge. The start is also a little bit better. It's not perfect, but it is a little bit better. The funny thing was it didn't really increase the strength that much of it, and I kind of got a couple ideas. Now, I'm kind of a little bit lost on the results of this testing, but to me, it looks like this weld overall is a little bit thinner, so less metal. And likely what was going on because of my limited values, I was going by how wide the weld was to dictate travel speed. Well, because it was run hotter, the weld got wider the way I would like it, and I moved slightly faster. So my guess is what's going on here is that even though it had more penetration, it wasn't really like night and day difference, very little, and the penetration increase was kind of negated by the smaller weld that I deposited. Because again, if you look, you know, the actual weld material here in the middle where it's about equal is a little bit less. So that's my guess as to what's kind of going on here, but they basically both broke very close to one another. So in the case of stress towards the face, does preheat work? Well, if you have a 140 amp MIG welder, good frickin' luck welding 3/8 plate. And just to give you an example, running at 200 amps with the same 035 wire, it should have broke around 90 to 100. So staggering difference in strength. I mean, about a 30%, 25-30% reduction in strength, and doing multiple passes wouldn't necessarily fix that. All right, let's look at these two then. So these were both bent away from the face. We can see evidence here. The top of the weld's tearing off, and that's because the top toe is going to experience far more stress than the bottom toe due to how this plate is bending. It's trying to tear it here, not down here. No doubt a crack. Probably, I would say, a worse crack than appeared on a 200 amp MIG pass, but it did hold together. This one, on the other hand, did not. And it didn't peel off here. It actually cracked down the weld. Now, I have a couple theories as to why this may have happened. The first one being for the same reason the first two plates. My travel speed likely increased a little bit because of how wide the puddle was. And that, in turn, the depth of weld or the thickness of the weld I deposited was more on this than here. Therefore, this was right at the limit for the thickness of it before it would just tear. That's my guess as to what happened. Although I will say this, bending the other two plates over there, it seemed to me like the preheated plate that the weld was a lot harder. And I know that when you weld, okay, if you weld on preheated plates, the weld is going to be hotter, but it will also take longer to cool. And the longer it cools can affect the grain structure of the solidifying weld. And I'm wondering if it didn't make this less ductile and harder, so that once it experienced the max load, it basically just broke through the weld rather than flexing like this did and tearing off at the toe line. But I'm telling you guys, from a hand feel, this thing was as hard as a coffin nail, breaking the other two plates all the way on the preheated versus the not. So it had some sort of effect to the weld strength, but you can see this one clearly failed, and it's not just by a little bit. Let me zoom out. So when you look at these, and I know this is kind of a bad angle here, but I was able to bend this plate all the way up, putting even more stress on this weld on this guy, which was on cold plates, and this one failed. The weld itself is wrapped around a corner, pretty much the same on both of them. And you can see here, if anything, I mean, look at the little bit of weld there. I mean, the start of this was rough. So I would say it is a wider weld that likely just didn't have the thickness to it, the throat depth. So, all right, let's go to conclusion. So in conclusion, what did we learn today? Well, I learned that what you can come into something with expectations that you can be wrong and you can be far off base, and this is probably one of those things that I'm a little bit surprised at, but in some ways it does make sense. So let's just cover this briefly. Running the preheated plates in the previous test, we saw about a 6% increase in strength, breaking it towards the face. This, not really anything. Why is that? Well, I think that even though the toes are wetted out better in this case, which is a great thing, the penetration didn't really increase that much, which this is a test that really shows strength and penetration. So the reality is, thinner weld, a little bit more penetration by 1 or 2% equals not a whole lot different. So this is not too surprising, I guess. Now, bending away from the face, the hot plate here failed. The cold plate, it does show indications that the top toe of the weld is tearing off, but hey, it made it farther than this, and it made it to the same bend point as previous testings, like with the MIG wire with higher amperage. So I would say that this is a pass, this is a fail. This held on for a very long time, but it still is a fail. Now, I think a lot of the reason why this failed is probably because that throat depth of the weld was thinner on this by a little bit than this. I mean, when you look at this, it's got like a convex. This wasn't concave, but it was definitely thinner, and that likely contributed to it. This was pushed to the absolute limit of what it would hold, and that little bit of difference in strength could have caused the failure. So that's my kind of thought on it. And like I had alluded to earlier, when I was bending this, because this was bent all the way here, when I bent it flat, this preheated plate one, despite having a smaller weld, was extremely tough to bend, which is surprising because it didn't break at higher strength than this. But I can tell you it took more force to break it and separate it. So it seems to me like the weld itself had a change in maybe the hardness or the ductility of it. Something happened with all of that preheat that changed it, and I think that also likely contributed towards why that broke rather than this one, which held on. Now, where does that leave us? Well, I'll be honest with you guys. If I have a 140 amp MIG welder and I had to weld 3/8 plate, I probably would do a preheat, and then I would go with 2 passes over it in order to fill it up. And that's about the best you can do. I still would probably preheat it, and because again, these are all undersized welds for this thick, but is it really a night and day difference? I mean, you be the judge on this. Tell me in the comments what you think. But I don't know, man. This is a pretty wild result. Like, the difference is not what I expected. And I did meter my machine. It was indeed outputting 145 amps to do both of these, which is in the realm of 140 amp MIG welder's capability. So I don't know what to think. I still would probably preheat it, but man, it kind of has the same results as the 200 amp passes or so in the previous video where there really wasn't a huge difference on them. So interesting. With that said, if you got any comments, questions, thoughts on this, you know where to leave them. Thanks for sticking around.